Hello, I'm Joe Hamaker, and in this presentation I'll be discussing estimating the cost penalty of entering space project full-scale development with immature technologies. First, a little bit about me. I'm the Director of DoD and NASA programs at Gallowrath Federal. Formerly, I directed cost at NASA, and I have over 40 years of experience with cost estimating and analysis. My email address is at the bottom of the chart, jhamaker@gallowrath.com. I'll repeat that at the end. Okay, so the NASA technology readiness level scale is shown in the image on the right. Most viewers are probably familiar with that. So this presentation concerns estimating the cost penalty of entering full-scale development of a space project, either purposely or unknowingly, prior to having matured sufficiently the technology. Now, there's another frequent cost topic that's quite different from the one I'm discussing today, and that topic is estimating the cost of technology advancement along that scale on the right. So what does it cost to start out at a low TRL and get up to a higher TRL? So I have a presentation on that subject that's entitled Estimating the Cost of Technology Advancement for Space Projects. As it says in the top right-hand corner in the blue oval, I'm not going to present this chart. It's in here for completeness. It's one definition of the NASA technology readiness level scale. There's dozens and dozens of such definitions out there. This one is from the NASA website that I've cited at the bottom of the chart, and it discusses each of the technology readiness levels from 1 to 9. I'm also not going to present this chart, but this one documents the fact that, there's a NASA requirement that projects have a TRL of at least 6 prior to beginning full-scale development. And that requirement is in the document cited at the bottom of this chart, the NASA NPD 7120.5E. So what's the big deal here? Well, space projects spin up in terms of team size and thus cost as they proceed through the project lifecycle, which is shown in the image on the right. So in NASA, the life cycle begins with pre-phase A, which are concept studies, goes through phase A, phase B, phase CD, which is full-scale development, and then phase E and F, which is operations and closeout. So the technology advancement occurs before pre-phase A, at least the lower TRL steps, and then it continues during phase A and B, getting that last push up to that requirement of a TRL 6. But the big deal here is that if it's discovered that the TRL maturity is less than what one thinks once the team is spun up, there's a big standing Army cost penalty. So the heuristic model presented here is not directly based on hard data in any statistical sense, but instead it's based on my experience of having been involved with many, many projects which discovered that some of their basic components weren't ready for prime time after they'd started development. Often those components had worked okay on the laboratory bench, but once they got them in full-scale development, especially when they tried to integrate them with other spacecraft systems, things went wrong. Now, it's not straightforward to parse out how much of overruns in any project is directly related to such TRL issues, but this heuristic I'm presenting here is my opinion of what that damage is. Now, there's a rub, at least one in this. This heuristic that I'm going to present in just a moment is meant to apply to total project cost. And why is that? Well, that's because of the marching army syndrome. One showstopper stops the entire show. So am I saying that an entire project is below TRL 6? No, that's almost never the case. But the tripwire is that if any critical component or assembly or subsystem is below TRL 6, then this heuristic applies. So now this assumes that the component, assembly, or subsystem that's below TRL 6 can't be substituted or descoped. So how do you know when you have such a tripwire? Well, there's the rub. I have mainly used the heuristic as a basis for cost sensitivities when I've been serving on an independent review team, and they, subject matter experts, have questioned the project's claims that everything is at TRL 6 or above. So then that team usually turns to me as a cost representative on the team, and they say, well, we don't think this project really is at TRL 6. We think it's at something lower than that. And can you shed any light on what you think the cost impact of a lower than TRL 6 status would be? So that's what this heuristic can be used for. All right, now this is a fairly complicated chart. It's obviously an Excel spreadsheet, an image of an Excel spreadsheet, and I'll be happy to send you the tool if you would like the actual tool, so you can email me for that. But let me walk you through the chart. Let's focus on the green cells in the dead center of the chart. Notice that spreadsheet rows 11, 12, and 13 and 14 are TRL ratings of 6, 7, 8, and 9 respectively. And then notice that the columns C, D, E, F, and G have to do with the degree of new design. So in all new design, starting on the right column G, in all new design, when I'm faced with estimating the cost of that, I usually say that's 100% new design. Then if the review of the say we're at PDR or wherever we are when we're doing the estimate, if the documentation convinces me that they are a major mod instead of an all new design, for example, I might lower that new design factor from 1 to 0.8. So I'm in cell F11 now. If there is even more heritage, let's say it's a significant modification instead of a major modification, I might go a little bit lower to a 0.6 new design factor, and on down. So minor mod might go to 0.4, and existing design probably goes to about a 0.2. Why does it go to 0? Well, you still got to do a lot of engineering to get the requirements defined and vendor selection and all kinds of engineering work, even if you're using an existing design. So I rarely go below 20%. Now, notice in the red area of this chart, there's a bunch of NAs. And these cells are referring to the cost penalty that we might elect to levy on the project if they're not at TRL 6 or above. So if you're using an existing design or minor mod or significant mod or even a major mod, it's, theoretically, you're TRL 6 or above. Now let's take a quick look at the box on the right-hand side of this chart, though, on that subject. So I am assuming in this heuristic that if the project is either using existing design, which is column C, or modifying an existing design, columns D, E, and F, then there shouldn't be any TRL issues. TRL issues should only arise in column G when we're dealing with a new design. Now, of course, sometimes projects claim to be modifying an existing design and later find that they really can't use that and they move to a new design. So this is just one more thing to consider. But let's look at cell G10. That cell has a adjustment factor, a penalty factor in it of 1.2. And that I'm suggesting that's about right for a TRL level of 5. If there's significant critical components that are only at TRL 5, that would add about a 20% cost penalty in my judgment. 40% might be more like it for if they have some components of TRL 4, and then on up the scale to 1.7, 2.1, and 2.5. Now, the algorithm for those numbers is shown there on the right. It's 1.2 raised to the power of 6 minus the TRL, the actual TRL. And you get that actual TRL, again, if you're working with some subject matter experts on an independent review team. Normally, that's the source of such information. So we'll take a look at this heuristic a little bit more on this next chart. There's some more information at the bottom of this chart, an example of TRL levels for a propulsion system, but I'm not going to take the time to present that today. Okay, so the basic mathematical formulation of the heuristic, as I mentioned on the previous chart, is x raised to the power of 6 minus TRL, where TRL is the actual TRL that the assessment team has given you. Now, this coefficient x can be set anywhere from 1.1 to 1.3 in my experience, depending upon your sense of doom. I generally use 1.2. So let's look at the table on the right. So if you're on 1.2 is the center column there. And so if you're way down at TRL1, you're the first row, you're 5 steps away from TRL6 where you need to be. So the penalty factor is pretty high there. It's 2.5. Same numbers as on the previous chart. It goes down to 2.1 if you've got a TRL deficit of 4 steps. It goes to 1.7 if you got a TRL deficit of 3 steps, and so on, down to no deficit, which would be the last row in the chart in the table, zero row, where you use a 1.0 for the penalty factor. So, for example, let's consider a project that's entering full-scale development, claiming TRL 6 or better. And let's say they have an estimated development cost of $100 million. But maybe you're serving on a team of subject matter experts, a non-advocate review team, and after considering the project, they advise you that there are some critical components that are way down the scale at only TRL3. And they turn to you and say, well, what would be the cost penalty of that? So you take, in this heuristic, you take 1.2 and raise it to the power of 6 minus 3. That's 1.2 then to the third power, which yields a 1.7 penalty factor. So 1.7 times $100 million gives you $170 million for the cost of the project, or a $70 million penalty. Okay, so final word here. Galarath is a 75-person company dedicated to providing our customers with best practice cost analysis. I've listed some of our experience base there. You can scan down that list for yourself. If you'd like to know more about Galarath, you can take a look at our website, www.galarath.com. If you'd like to contact me, my email address is jhammaker@galarath.com. I'll be glad to discuss this heuristic, give you a copy of an actual spreadsheet if you'd like that, or any other subject on cost estimating of space projects. Okay, thank you very much.